Hi everyone, this is Ms. Nichols and this is your very first flipped instruction video lecture of the year. The topic is variables and units, which may be a concept familiar to some of you and it may be new to others, but in any case we'd like you to practice your Cornell note-taking as you watch this video. The first thing is the essential question for this lecture, and the essential question is, what is a variable? And how do I identify and label one? In science, every number can be considered either a constant or a variable. If a number is a constant, it's something that has a set value that doesn't change. If a number is a variable, its values depend on other things and they may be changing over the course of time. For example, the word dozen refers to a constant. It's always the same number of items. Or a dollar. We always know how much a dollar is. It doesn't change in size. A person or an animal or an object could also be considered a constant. Compared to variables like height. Now height is a variable because it depends on the shoes that you're wearing or your age. So it changes over the course of time. Money in general is a variable because the amount of money that you have is going to change based on how much you've earned and how much you've spent. Or the speed of an object is a variable because it depends on whether that object is stopped or going on a highway or just barely walking. So it's something that, so the variable speed can change over time. I often refer to physics as the science that explains the way the world works. Now, the world around us is full of variables. You know, values that are changing, objects that are being impacted by other variables all the time. And so our goal in this class is to try to understand how some of these variables can affect others. Interestingly, despite the fact there's lots of different things that we can measure, there's only 6 what are called the fundamental variables, and those are the 6 variables that really can describe the properties of any object in the entire universe. So even advanced physics is really just the study of these 6 variables and how you can combine them and how they interact and how they affect each other. The first of these variables that we'll be using a lot in this class is time, which of course you're all pretty familiar with the concept of time and how that works. The second one is distance, which is how far apart 2 objects are. The third one is mass, which is how much stuff is inside an object. And actually, the majority of this class is going to be just those 3 variables and the combinations of those 3 variables and how they affect how they affect each other. There is one more variable that we'll be using relatively frequently, and that's known as charge. Some of you may have heard of it before, but has to do with electrons and protons inside an atom. And then there's 2 more variables that only occur at really, really tiny scales, and we won't be talking about them, but I thought I'd mention them. There's something called color and spin. Those don't necessarily mean what you think they mean as far as color or an object spinning. They refer to something on a really, really tiny scale, subatomic scale. But those are it. Those are the only 6 variables that describe everything in the entire universe, and most of them you've probably already heard of and maybe even used before. That doesn't mean those are the only variables we'll be using in this class. It just means that any other variables that we'll be using can actually be created by combining those 6 variables in different ways, and you'll learn about that in a video a little bit later on in this unit. Every variable or number that we'll be using in this class comes with units. The number's unit gives it meaning and it gives it a physical size in the world, and I'll explain a little bit more about that in just a minute. You can also use the unit of any number to help you identify what the variable is if you're feeling a little bit lost or confused. So here's an example to illustrate how important units are. If a person tells you, I'm going to give you 6, hopefully your first question is 6 of what? Because it makes a big difference. And this person told you a number without telling you a unit. They could have been giving you 6 pieces of candy, for example. And if that's the case, candies is the unit, right? 6 is the number, and candies tells you what it is, and it also tells you how big it is. Like candies is a different unit than bags of candy, so that would determine how large of a quantity of candy that you're getting. And of course, the units is a big deal, because if we didn't tell you we were going to give you 6 candies, maybe we were instead planning to give you 6 bags of poop, which would be a significantly less pleasant object to be receiving. So in the second case, bags of poop is the unit. In the first case, candies is the unit. They both have the same value, but the units really helps you determine what the object is and how much of it we're talking about. Okay, now that we've got some of the basics and fundamentals down, let's talk about some specific variables that we're going to be using in this unit. So our first unit is on movement, and we are going to be using 3 different variables during this unit. Time, which we've already talked about a little bit, distance, which we've also mentioned, and a third variable, which is velocity. And velocity is not one of the fundamental variables, which means it's sort of made up of the other variables that we know. Some of you may already have a sense of what velocity is, but we'll get into that in a lot more detail in this unit. Time is actually a variable that has really confused and perplexed scientists for a long time, evidenced perhaps by this painting by Salvador Dali. What is time is a really deep question, and people have struggled really to answer that. Most people refer to a clock, but of course if we have different clocks, who's to say what time actually is? In general, we're referring to how long something takes to occur, and the typical units are seconds, minutes, or hours. The asterisk indicates the unit that we'll usually use in this class, so we're mostly measuring things in seconds, because most experiments and stuff that we are going to be undertaking will happen over a period of seconds, not minutes or hours. But all of those units are completely valid and can be used interchangeably depending on what data or information you are trying to figure out. The second variable for this unit is called distance. If you've had a science teacher before that emphasized the difference between distance and another variable called displacement, great, you'll do more of that in AP Physics. But for the purposes of this class, we're going to use them to mean the same thing, which is basically how far apart 2 points are. Typically in science, we measure distance in meters, but you could also use miles or centimeters to measure things that are different sizes. We prefer you to be in the metric system, which is meters and centimeters for this class, because it's got some real benefits when it comes to conversions, which we'll talk about later on. Since meters is our typical unit for distance, it's useful for you to have a sense of how big a meter is. And so there I am holding up a meter stick. So a meter is about the length of my leg, kind of from the hip to my toe. So I'm an average size person. Maybe that can give you kind of a sense about how big a meter is. The third and final variable that we're going to be using in this first unit is velocity, which is a word you've probably all heard. It means basically the same thing as speed, how fast an object's going, but a more precise scientific definition is how far an object moves in a certain amount of time. You'll notice we've got distance and time in there, which is why this is not one of the fundamental variables. It's made up of those other 2. The typical units of velocity that we'll be using in this class are meters every second. So that means, how many of that meter length distance an object goes in 1 second. Sometimes that's written m/s, and sometimes it's pronounced meters per second, although I prefer meters every second because it's a little bit more descriptive of what's happening. You're all probably more familiar with the units miles every hour or miles per hour, because that's what cars have, and speed limit signs, etc. And just for your reference, 1 meter per second is about 2 miles per hour. So a car going 60 miles per hour is actually covering about 30 meters per second. You're probably aware that this class and many of your other classes are going to be evaluating you based on a series of proficiencies. Some of those proficiencies in this class will be content, so things that you're going to learn about, and others will be skills that we're expecting you to be learning throughout the course of the year. One of those is mathematics in science, so this is proficiency SE2, and that proficiency is broken into 4 little sub-proficiencies, one of which says I can identify the name, symbol, value, and units for variables in a word problem. So for example, if you read the little sentence fragment below, if you read the hippo was 2.5 meters long, what I'm expecting you to be able to do is to be able to tell me, based on that sentence, what is the name of the variable, what is the symbol we're going to use to represent it, what is the value of that variable, and what are the units. A hint on this, I would look at the units first. They tell you a lot of the other information, right? We see the number 2.5, but that's not the most important thing in the sentence. The word meters that follows it tells me that I'm talking about distance, and that should help me fill in the rest of the table. So what this table would look like if you were filling it out, the name of this variable is distance, which we talked about a few slides back. The symbol for distance is actually a lowercase d, so when you make an equation for distance, it'll always be lowercase d. The value of the distance in this case is 2.5, and the units are going to be meters, or you can use a lowercase m for short. Another example problem with a different variable from this unit, if you read something like the onion rolled down a 20-meter hill in 40 seconds, okay, hopefully you see there's two different values in there, but they are telling you about the same thing. They're actually telling you how many meters every second that onion is rolling. So hopefully that's your clue. You know, got meters and seconds. The clue is we're talking about the variable velocity in this case. So you read that whole sentence. We're not writing down distance and time separately. What we'd write down is the name of the variable is velocity, the symbol is v, and then you need to think to yourself, how many meters every second is that onion traveling? Well, it's going 20 meters in 40 seconds, so 20 divided by 40 is 0.5, and the units are going to be meters every second. So we're going a half a meter every second, right? It takes us 40 seconds to go 20 meters. The third example says it took 45 minutes to get to the front of the line. Of course, you look at the units first. You see the units are minutes, and minutes is the unit for time. So we've got the name is time. The symbol for time is going to be a lowercase t. The value is 45, and the units for this are minutes. Okay, so we made it through our first video. Hopefully you have refreshed some things that you already knew, or maybe learned a couple new things, but take a minute and revisit that essential question from the very beginning. What is a variable, and how do I identify and label one? What are going to be the important things in this course for keeping track of these variables that we'll be using throughout the year? Thanks for watching.